Another type of pneumatic cylinder is the double acting cylinder or DAC. So recall that the previously discussed pneumatic cylinder is a spring return type cylinder or the single acting cylinder. So the double acting cylinder differs actually uh, in compared to the single acting cylinder only by means or only the means of retraction or the way wherein the two cylinders will be retracted. So both the single acting cylinder and the double acting cylinder can do extension or they can extend or operate in extended position, okay, or the two cylinders, okay, so the single acting cylinder and the double acting cylinder can also do the reverse, which is the retraction process or the retracted operation. However, as I've mentioned, um, the two cylinders differ in the process wherein they are being retracted. So if you try to recall, in the single acting cylinder, the process of retraction not for the cylinder is by means of the spring. Okay, so wherein you have to cut off the source of air, okay, and then you let the spring of the single acting cylinder to push back the piston rod for the cylinder to retract. Okay, so but for the double acting cylinder, that's the different means. Okay, so in the double acting cylinder, it uses the force of air, okay, to enable the cylinder to extend, and at the same time, it uses the force of air, okay, to enable the piston rod to retract. So the difference is that the single acting cylinder uses the spring, whereas the double acting cylinder uses, of course, the air to enable the cylinder to retract. Okay, so based on the physical construction, the single acting cylinder only it only have one port. Okay, so but for the double acting cylinder, it has two ports. Okay, so one port is used as an inlet of the air uh, for the extension process, no, of the cylinder, and the other port is the inlet of the air for the retraction process. Okay, so this is how we. Okay, so this is how the double acting cylinder operate. Okay, so air is used to enter in this direction. It pushes the piston rod. Okay, so allowing the piston rod to extend, and then to make the cylinder to retract. So air is allowed to enter in the other direction, so which is in the second port. Okay, so it pushes back. Okay, so the piston rod. Okay, so to its initial position. Okay, so that's the operation, no, of the double acting cylinder. Okay, so as you can see uh, in the picture, okay, or in the figure, so there are two ports available for the double acting cylinder. One is given in this side, and then the other is in this side. Okay, so air will enter to this port, and then it pushes the piston rod, allowing the cylinder to extend, and air will enter. No, so also in this port. Okay, second one, so allowing the cylinder to retract. Okay, so uh, if you okay, so before we discuss the type of solenoid valve that is paired with the double acting cylinder. So this is the animation on how the um, double acting cylinder works. Okay, so as you can see, air is both or air is used both in the extension process and the retraction process. Okay, so now for the solenoid valve, okay, so we have defined, okay, so the solenoid valve last time as the as an electromechanical device, okay, so that is built in with a coil. Okay, so this coil is we will call this one solenoid. Okay, and a pneumatic hydraulic directional control valve. So we term this one as the plunger, okay, of the solenoid valve. So the solenoid valve is the intermediary part, no, so of the pneumatic system. So that means you have it, okay, so you have it in the pneumatic power section, and you have also the solenoid valve in the control circuit. Okay, so let us just run through. Okay, so the components of the solenoid valve. So you have there the coil, okay, and then the service port. So again, this is where the double acting or the cylinder, no, so is connected. So in the figure, so since we have two service ports, no, so that means this solenoid valve is intended for the double acting cylinder type. Okay, so and then we have here the inlet port. So this is connected to the compressed air source. Okay, so this is how the solenoid valve works. No, so you energize the coil. Okay, so this is the plunger. Okay, so it actually is being attracted, no, so by the magnetism created by the coil. Okay, so once the coil is energized, it attracts the plunger, and then once the plunger is moved, then it allows the flow of air. Okay, once you de-energize, okay, so once you de-energize the source, I mean the coil of the solenoid valve, so the spring, okay, so will push back the plunger to its original position. Okay, so for the single acting cylinder, so we have, as discussed last time, so we have there the three two-way, no? So three two-way solenoid valve. So this is used to control, no, so the operation of the single acting cylinder. Okay, so for the for the double acting cylinder type, okay, so there is another type of solenoid, no, so or we have a specific type of solenoid valve that must be paired with, okay, so the double acting cylinder, and that will be discussed, no, so in a while. So if we try to recall, no, for the single acting cylinder, so we have the three two-way valve. So three stands for number of port, then two stands for number of position. Okay, so these are the parts, no, so the three two-way solenoid valve. Okay, so yeah, there are three ports. So service port, the inlet port, and then the exhaust port. Okay, so the solenoid valve. Okay, so here comes the solenoid valve that is used to control the position of a double acting cylinder. Okay, so for a double acting cylinder, so we use, no, so we use the five two-way, no, so five two-way solenoid valve. So the same way as with the three two-way, the number five here represents the number of ports, no? And then two stands for the number of position. Okay, so the number of position uh, is given by the extended position and the retracted position. Okay, however, unlike with the 3 two-way, no, so solenoid valve. Okay, so the 5 two-way, no, so 5 two-way solenoid valve comes in two, no, so two different or two categories. So the first type or category of a 5 two-way solenoid valve is the single coil or spring return valve. Okay, so actually the 3 two-way, no, so the 3 two-way solenoid valve is also a single coil spring return valve. Okay, because if you try to take a look at the operation, no, so try to take a look at the operation of the 3 two-way, for example, this one. Okay, so you have here single coil, no, or basically one coil, and then the plunger is being returned to its original position by means of the spring. So that's why you have their single coil but spring return. Okay, so however, that is, or the 3 two-way is intended for the single acting cylinders. Okay, so the 5 two-way, on the other hand, okay, the first type, the single coil spring return 5 two-way solenoid valve is intended for the double acting cylinder. Okay, so this is the typical appearance, no, so of the the typical appearance, no, of single coil spring return 5 two-way phase solenoid valve. So you have there two ports. Okay, so basically the difference between the 5 two-way single solenoid and the 3 two-way single solenoid is that the number of the service port, no, so you have there two for the 5 two-way and then one for the 3 two-way. Okay, so as I've said, the 5 two-way is of course intended for double acting, and then the 3 two-way is intended for the single acting cylinder. Okay, so the second type of the 5 two-way solenoid valve is the double coil. Then notice that you do not have the spring return. Okay, uh, when you have the double coil, then that means it's not spring return type. Okay, so the typical example, no, so of the double coil is shown, no, so in the picture at the right side. Okay, so you have the two coils. So you have the one coil, this one. Okay, so you have the first coil, second coil. So first coil, second coil. And then for the single coil, so you only have here coil number one. Okay, so but it's spring return type. This one, this is not a spring return type. Okay, so meaning to say, this solenoid valves, no, so the single coil and then the double coil, so they are exactly, or they do have, no, so both of them do have the plunger. Okay, but then for the spring return or the single coil, it is the spring that makes or returns the plunger into the original position. Okay, but in the double coil, so since there is no spring, okay, so and therefore another mechanism is used to enable or to return or to make the plunger return to its original position. Okay, so we will be discussing it, no, so in a while. Okay, so this is how the solenoid or the 5 two-way, no, so single coil works. Okay, so as you can see, so this is the internal configuration, no, so of the 5 two-way single coil. So this is the plunger, okay, so that we are talking about. So this is the coil, no? So once you energize the coil, so the plunger is of course attracted, no? So as you can see, the plunger moves, no? So once it moves, so it's either it allows the air to flow in this direction, okay, this one, so making the cylinder extend, and then when you turn off, no, again, once you turn off the supply, so the spring, this one, so pushes back, no, so the plunger to its initial position, no. So once it push back, no, so the plunger, so as you can see, the direction of the air changes, no. So initially the air flows in this direction, okay, so allowing the cylinder to extend. But when you turn off the supply, okay, so just like in the 3-2-way solenoid valve, when you turn off the supply, the spring pushes, no, so the plunger to its original position, thereby allowing the air to flow, no, so in the reverse direction, no. So you can see you have here, no, so you have here the flow of air, no, so as shown in this animation. Okay, so when the air flows in this direction, okay, so it enables the cylinder to retract. Okay, so the operation of the 3-2-way and the 5-2-way, also solenoid valve, so they are exactly the same, but then they differ. No, they just differ as to the construction, because the 5-2-way, as we've mentioned, is used to be paired with, okay, the double acting cylinder, and then the 3-2-way is of course used to paired with the single acting cylinder. So that is for the single coil, no, or spring return solenoid valve, or 5-2-way single coil valve. Okay, so so the next type, no, so the next type of solenoid valve or 5-2-way is the, you have here the double coil, no? As you can see, we have now two. So we have now two coils. So we have the coil 1, and of course the second coil, coil 2. Okay, you notice that the plunger steel is inside, no, or built in, or the double solenoid 5-2-way valve is also built in with a plunger. Okay, so this one is the plunger. Okay, so this one. Okay, so this is the plunger actually, the movable, no, so plunger. Okay, so let's try to take a look, no, so as to how the double coil, the double solenoid 5-2-way valve works. Okay, so okay, so how do this solenoid valve works? Okay, so assuming that we energize, no, so we energize the coil. So let's say we energize this coil first, no? So the one that is located at the left, no? So this one. So once you energize this coil, so it attracts the plunger in this way, no? So meaning to say, the plunger will be moved in this direction, allowing the air to move here, and then push the cylinder in extended position. Okay. Now, unlike with the single coil, that when you cut off the supply, okay, so you have to take note of this one. No? So when you cut off the supply, uh, the plunger, this one, does not. No? So it does not return to the initial position because there is no spring present inside the solenoid valve. Okay. So meaning to say, even if no, so even if the power is being cut off, so assuming that the cylinder, no, assuming that the cylinder is still on the process of extending, so long as there is air, okay, so long as there is air flowing, even if the source is being cut off, then the cylinder will continue to extend. Okay, so if you try to remember in the single coil, when the power is cut off, so the cylinder will retract. Why? Because the spring, okay, so the spring of the solenoid valve enables the plunger, no, so to go back to the original position. And once the plunger go back to the original position, then the air, no, let us say the double acting cylinder, the case of the double acting cylinder, so the air will flow, no, so in the reverse direction, allowing the piston rod to uh, be pushed back, no, so thereby enabling the cylinder to be in the retracted position again. But then in the 5-way double coil or double solenoid, the okay, the plunger, no? So the plunger of the solenoid valve uh, does not go back, no? So to the initial position. So the only way for the plunger, no, so of the solenoid valve to be returned, no, to the initial position or to the other direction is to attract it, no? So uh, to attract it by means of the other coil. No? So, which means that when you energize this coil, so the plunger moves, okay, or attracted in this side, allowing the cylinder to extend. So there is no way for the plunger to return, no, so to the original position. So the only way for the plunger to return to the original position is to energize, no? So we need to energize the other coil, okay? That means one of the coil is for the extension process of the cylinder, and then one of the coil is of course for the opposite operation, which is the retraction. So what will happen, by the way, no? So what will happen if you energize both of the coil at the same time, okay? So you energize, assuming that you uh, energize the coils, not the two coils at the same time. So the plunger, okay, will not move. Okay, so it will not move, thereby, uh, okay, thereby freezing. No, so thereby it freezes the status, no, so of the cylinder. So if the cylinder is in extended position, assuming that it is already in extended position, and then you energize both, it will remain now so in extended position. Okay. Or if the cylinder is in retracted position and then you energize both, then the cylinder will remain in the retracted position. So thereby, to wrap it up, so for the 5-2-way, no, for the 5-2-way solenoid valve, so we have the single coil, and then the other type is the double coil. Okay, so which one is used also in the industry? So that depends on the application. No, so if the application is sensitive to, let's say, power interruption, that means let us say, no, so the cylinder, the cylinder is in the process of extending. Okay, so let's say you energize the coil and then the cylinder extends, and then suddenly there is power interruption, and then you want the operation, no, so you want the cylinder to return to its normal state, which is the retracted position when there is the power interruption, then you need to have the single coil. No? So because in single coil, the only thing that can enable the cylinder to extend is by energizing the coil. No? So once you de-energize the coil, so it enables the cylinder to retract. But then if the operation requires, no, so let's say you have there an application wherein once you energize the solenoid valve, so it enables the cylinder to extend, and then there is suddenly a power shortage, no? Or the sudden cut off, no? So in power supply, and then you want the cylinder to remain in extended position, then you need to have the double coil. Okay, so because in the double coil, as I've said, once you energize, no, so the one coil, so it commands the cylinder to either extend or retract. Okay, so the other direction, let's say the cylinder extends, no, when the first coil is energized. So to enable the cylinder to retract, so you must energize the other coil. Okay, so that depends, no, that actually depends on the application, no, so to the double coil cylinder. Okay, so uh, depending on the what do you want, no, so the for the cylinder, when for example there is a sudden uh, cut off, no, so in the power source, then you will be deciding as to which of the 5 two-way valves will you need. Okay, so as we mentioned, or as I've mentioned a while ago, 5 stands for the number of ports, 2 stands for the position. Okay, so this is the symbol, no, for the what they call this one, the 5 two-way solenoid valves in fluid sim. Okay, so for the single coil, so you only have one coil. For the double coil, of course, that's 2. Okay, so you have there the inlet port. Okay, so and then the exhaust. No, so as you can see, there are 2 exhaust port. No, so when you extend the cylinder, so the air in the other side will be exhausted. No, so at port number 3. So when you want the cylinder to retract, no, so the air on the other side also will be exhausted at port number 5. Okay. So and then we have the service ports, no. So these are the ports that is connected to the double acting cylinder. Okay. So and then as you can see, no, for the single coil, so you have the spring and then the manual button also. This one. Okay. So now we will try to examine the advantage of having a double acting cylinder as compared to the single acting cylinder. Okay, so we'll try to simulate uh, pneumatic applications or operations using the fluid sim simulator. Okay, so let me share the. Okay, so now uh, first we need to construct, no, so for us to see the difference, no, so in operation with regards to the cylinders, we need to construct, no, so the power or pneumatic power circuit. Okay, so the first one is a single acting cylinder. Okay, this one, and then you have the double acting cylinder also. Okay, and then the 3 two-way, no, solenoid valve. So we go to solenoid operated, this one. Okay. So this is used to control, no? So the single acting cylinder, and then we have the 5-2-way, no? This one, 5-2-way solenoid valve. Okay. So, and then the compressed air source, this one. Okay. So we try to connect, no? So the compressed air source to the inlet, okay, of the, okay, 3-2-way, and then we can also connect, no? So the single coil 5-2-way to the same compressed air source. So you can click it here, this one, and then connect, no? So one is connected to, or one service port, no? So it's connected to the other port, no? So the one of the port of the um, pneumatic or double acting cylinder, and then the other service port is of course connected to the second uh, port of the double acting cylinder. Okay, so let's try. So we'll try to simulate, no? So the operation of the two cylinders. As you can see, for the single acting cylinder, so we try to operate it manually. Okay, so uh, clicking, no? So this manual button, that means energizing the that is the same as energizing with the coil. So that enables the cylinder to extend. Okay, and then once you release it, the cylinder retracts. Okay, how about the double acting cylinder, this one? Okay, so energizing the coil, so it enables the cylinder to extend, right? But you de-energize the coil, you release the manual button. Okay, so you click, so the cylinder extends, and then once you release, the cylinder retracts. Okay, so basically, if you try to observe, no, so the operation of the single acting cylinder can be done by the double acting cylinder with a single coil, no? So, or the other way around, in the absence of the double acting cylinder using single coil, right? It can be replaced by, no? So it can be replaced by single acting cylinder with 3-2-way valve. So what makes the advantage, no? What makes the double acting cylinder advantageous as compared to the single acting cylinder? Okay, so you can see now in the single acting cylinder, we can control, no? We can control the speed, no, of the cylinder by adding the what we saw called as flow control valve, no? So we just click the connections and then delete. So the flow control valves, no, so can be found, okay, so under shut off valves and flow control valve, okay. So wherein we can use this one-way flow control valve, this one. So just click this one and then drag it here, and then you can rotate it, no? So by 90, this one. Okay, and then you put it in between the solenoid valve and the cylinder. Okay, so uh, this is actually like, or the operation of the one-way flow control valve is the same as faucet, no? So in our house, no? So you open fully the faucet, no? So the water will come out, uh, or the volume, no? So of the water coming out will be uh, or the volume and the speed, no? So of the water coming out, no? So from the faucet would be uh, the volume is greater, no? So the speed is as faster as compared to you open the faucet 50% of the opening, or shall we say 20% of the opening. So the more you open the faucet, no, so the volume of the water coming out and then the speed also of the water coming out will be uh, uh, large, no, or that would be greater as compared to when you open the faucet 50%, no, or just a portion, no, so of the opening or the full opening of the faucet. Okay, so you can adjust the opening, no, so of the flow control valve. So you just double click it, and then um, you can click display opening level. So let's say you just need to have 20%, no, shall we say 10%, no, of the opening. So let's try to see as to what speed we can control the single acting cylinder. Okay, so okay, we'll just click OK. Yes. So as you can see, so the speed of the single acting cylinder is reduced. Now, so compared to 100%, okay, let's say 100% opening. So the speed, as you can see, no, so the speed of the single acting cylinder is faster. No, so during the extension process, try to take a look at this one. Okay. So, but then you change the opening to 10%. No? So let's say 5% no, of the opening. Okay, so as you can see, no, so you can only control the speed or the forward stroke, no, so of the single acting cylinder, but the speed, no, so of the cylinder uh, in the reverse stroke, no, or the retracted operation, that is or that will remain as is, no, so regardless of the opening of the flow control valve. Okay, so try to compare it with 100%, no, so let's say, okay, so then compare it with, shall we say, 5%. Okay, so as you can see in the single acting cylinder, to control the speed, no, so that would be difficult, no, so to control the speed of the uh, single acting cylinder, because the one that enables, no, so the cylinder to retract is the spring. So, but unlike with the double acting cylinder, as you can see, you create two, no, so two flow control valves. Okay, then connect it, no, so to the cylinder, and then the other end to the solenoid valve itself, no, so the service port, no. So we make it 100%, no, so at first 100%, and then let's try to observe, no, how the cylinder works. So you energize the coil, cylinder extends, you de-energize the coil, the cylinder retracts. Okay. So now, okay, so we'll try to adjust the speed, shall we say 5%. Okay. And then the other one to, let's say, 10%. Okay. And then you try to, okay, so, and then you can change this one to 5% again. Also, and then, okay. So if you notice, okay, so or to control the speed, okay, so in the extension and retraction of the double acting cylinder is easier as compared to the single acting cylinder, no? Or let's just say that when you use the double acting cylinder, the advantage of it as compared to the single acting cylinder is that in the double acting cylinder, you can control the speed for the extension process, and then you can control also the speed for the retraction process. So that's the advantage, no? So of having the double acting cylinder as compared with the single acting cylinder. Okay. So take note, no? So take note, the double acting cylinder and the single acting cylinder can replace each other, provided that, okay, so the double acting cylinder uses the single coil type, no? So which means the operation of this single acting cylinder, this one, okay, so this can be replaced by this one or vice versa. Okay, so now we'll try to take a look at the other type, no, of the 5-2-way. So another type of 5-2-way, as discussed a while ago, is the double coil. Okay, so we'll just have to create another pneumatic power circuit, no, using double acting cylinder, and the let's just copy this one, Control C, Control V, no? So okay. Okay, and then we have the double coil, no? So double coil solenoid valve or 5-2-way double coil. So you have here the 5-2-way solenoid impulse valve, this one. Okay, so just click it and then drag it, no? So and then again, no? So we have um, flow control valves, no? So in between the solenoid and the cylinder, then we connect it to the same compressed air source, no? So okay, so let's try to take a look at the difference between the two, the operation, I mean, of the two double acting cylinders, which utilizes single coil and the double coil. Okay, for the single coil, let's click the simulation button. Okay, so when you energize one of the coil or one coil, the cylinder extends, and then when you de-energize it, the cylinder retracts. Okay, so for the double coil, you energize this one, coil A, and then you release. As you can see, the cylinder remains in the extended position. Okay, to enable the cylinder, no, regardless of, okay, so to enable the cylinder to retract, okay, so to retract, so you must energize the other coil, this one. Okay, okay, so you energize and then you de-energize. Okay, so normally, okay, so normally we name, no, so we name the coil. So assuming this is, let's say, uh, okay, so this would be cylinder A, copy this one. This would be cylinder B, let's say, no, cylinder B. And then cylinder C. Okay. So in pneumatic applications, no? So we just have it here, cylinder A, cylinder B, cylinder C. Okay. Now in pneumatic applications, normally we label, no? So we label the coil of the solenoid valve. We label it either plus or minus, no? So we label the coil that can make the cylinder extend. We use the notation plus, no? So that means when you energize that coil, that will enable the cylinder to extend, no? So in this case, we can label this one A plus. So energizing A plus, so it will enable the cylinder to extend. Okay, so this one, we can label this one B plus, and this one, so we can label this C plus. No? So, but since the cylinder or the retraction process of the cylinder is different, so we use the notation minus to indicate that that particular coil is used, no, so or must be energized to retract, no, so or to enable the cylinder to retract. So in this case, we can create the name C minus. Okay, so that means when you energize C plus, okay, the cylinder extend, and then we energize. When you energize C minus, the cylinder retracts. So for the single coil, as you can see, we do not have the minus notation, no? So it's only A plus and then B plus. So the explanation is that for single coils, no, so you just have to de-energize, no? So you only have to de-energize the uh, coil, no? So for the cylinder to retract, okay? So just like this one, no? So A plus, that when you energize A plus, cylinder extends, you de-energize A plus, so the cylinder retracts, okay? Like this one, okay? Okay, so that's the operation, no, of the cylinders, double acting cylinders, with the corresponding 5 two-way solenoid valve. Okay, so we'll try to have more examples, no, so as to the operation, no, of these cylinders. Okay, so from now on, we'll try to omit, no, so we'll just omit the single acting cylinder. Okay, so knowing the fact that it can be replaced by a double acting cylinder with single coil. Okay, so the operation of this one is the same as with this one. No? I mean, the final output is the cylinder process or the cylinder operation. So the double acting can replace, no, so the single acting cylinder. Okay, so okay, so we'll try to have example, no. So we try to label. Okay, so we'll just label. Okay, we'll just delete, no. So this one. Okay, so Okay, so we'll just name this one cylinder A. We'll just have it cylinder A, and then this one we'll just have it cylinder or coil A plus. This one we'll name this one cylinder B, and then we label this one B plus and C plus. I'm sorry, C B minus. Okay, no? So okay, so as discussed last time, we can monitor, no? So we can monitor the um, position, no, or the current status of the cylinders using the proximity sensors. Okay, so depending on the position, no, of the sensor, so we can either use the read switch or the limit switch, no. So we'll use limit switch and read switch, no, so to both of the cylinders. So we can make use of distance rule, no? So in this case, distance rule. So since the position of the sensor is above the cylinder, that means this is a read switch, no? So by the way, if you try to look at the parameters, no, parameters of the double acting cylinders, that's 100 mm in length, no? So leave the other parameters as is, no? So this one is also 100 mm. Okay, so we open the distance rule. So we click this one A. So that would be AO. So again, no. So AO or 0 is used to indicate uh, sensor to monitor the retracted position. Okay. So it begin with 0 and end with 0, and then A1. So 1 is used to, by the way, A stands for cylinder A, no? So this, therefore, these are the sensors connected to cylinder A. And then also this one. So A1 is used to monitor the extended part, no, or extended operation of the cylinder. So you have there 100 and with 100. So where do we get this 100? No, so this is actually the length of the piston rod, no, or the stroke. Okay, so we click OK. As you can see, you have the reed switch, no, position above the cylinder. Okay, and then cylinder B will be utilizing the limit switch. So just place it there. Okay, in this position, it will automatically position itself. No, so double click. Then we use B0. Okay, and then B1. So that's 100 and with 100. Okay. As you can see, you have there the limit switch and then the other one, the read switch. Okay. So now we'll try to use, no, so electrical controls to enable, no, so the operation of the, or to enable, no, so the operation of the uh, or to further, no, so distinguish, no, the difference between the single coil and the double coil. Okay, so we go to the ladder. Okay, so up until now we are using, no, so the
ANSI, no, or American Standard symbol. Okay, so we just okay, so that's zero, positive and negative supply. Okay, so try to take a look at this one. No? For example, in this case, so we want the cylinder to extend. No, so we use push button. No, this one, and then the coil. So if we energize the coil, so shall we say A plus, and then this would be PB1. No? So basically push button 1. Normally open push button, so we connect the two in series, and then the other end connected to, okay. So if we try to simulate, as you can see, so the moment you release, no, so in the double acting cylinder, so when you energize the coil A plus, so it enables the cylinder to extend. Okay, so long as you press it, then it will remain in extended position. But when you release, as you can see, the cylinder, or even if the cylinder does not reach, no, so the fully extended position, like this one, once you de-energize the coil, the cylinder automatically, no, so it will automatically retract. Okay, so like this one. So the remedy, if you want the cylinder to continue to extend, even if you, what they call this one, even if you uh, release, no, so the push button, so we use the aid, no, of the sealing contact, no, so which is provided by the relay. So assuming you have the relay, so this would be relay R1, for example, no. So and then the contact, this one, so this would be read switch, read, no, so because I'm sorry, never mind, no, never mind, limit, this is the contact coming from R1, no? So just label it R1, so it will change, no? So to the relay contact, no? So the sealing contact is always in parallel, no? So in parallel with the, okay, this one. Okay, so the sealing contact is in parallel with the push button, and then the coil, as I've mentioned to you last time, it must be connected in parallel, no? So if you try to press the push button and then release, as you can see, the cylinder continues to extend with the aid of the sealing contact. Okay, so to enable the cylinder to retract, we need to de-energize, no? So we need to de-energize A plus. Okay, and then A plus can only be de-energized if R1, this normally closed R1 here, will become open, right? And then this will become open only if, of course, the coil R1 will be de-energized, okay? So how do we do it? So we can make use of the normally closed push button like this one, okay? So we can label this one with stop. So the normally closed push button, okay, so will break the contact. That means it will cut off, no? So the current flowing in the circuit. So to enable the normally closed push button to function, it must be connected in series, no? So with the one that you need to be de-energized. So if you try to ask, who are these components that we need to de-energize, that's actually A plus and R1. So we need to connect the normally closed, no, push button in series with them. So we cut off this part of the circuit and then insert the normally closed push button, like this one. Okay, so we try to simulate start or the cylinder extends, but when we cut off the source, so R1 is being de-energized, allowing this to be opened, and then of course once this opens, A plus is de-energized, then the cylinder retracts. Okay, so that's for the double acting cylinder using single coil. How about the double coil? No. So for the double coil, so let's say we'll just copy this one. Okay, so for the double coil, so we'll just use PB2, no? So to avoid conflict of PB1 here, and then let's try to delete, and then this one. Okay. So we try to follow the operation of the single coil 5-way, no? So the operation as we have simulated is that when we press this push button here, the cylinder will extend, no? And then when we press the stop button here, the cylinder retracts, okay? But when we implement that circuit, no, so the control circuit, no, in a double acting cylinder using the 5-way double coil, so the control circuit will be different, okay? So in this case, we will have two, no? So two coils no, coming from the solenoid valve. One is for B plus, and then the other one for B minus. No? So B minus, as you can see, that's B minus. Okay, so now we connect PB2 in series with B plus, like this one, no? So if you try to look at again the single coil, so for the cylinder to continue, no, so to extend, so we use the concept of the sealing contact, no, to maintain the operation of A plus, no. So without R1, so you release push button, A plus will be de-energized immediately. But if for the double acting using double coil, if you try to look at us, focus your attention in this circuit here. Okay, so we try to energize B plus, right? So by clicking PB2, B plus is energized, no? And then try to observe what will happen to B plus if PB2 is released. As you can see, okay, so even if we release, no, so directly PB2, making B plus to be de-energized, still the cylinder continues to extend. Okay, so as I've explained a while ago, the plunger of this one is attracted now so to the this B plus coil, and even if it is de-energized, since the 5-way no, double coil does not have the spring, so thereby it holds the position of the plunger. Okay, so meaning to say it still allows the flow of air to flow, no, so to the cylinder, no. So try to take a look at this one. When you energize B plus and then you release the push button, the cylinder continues to extend. So even if B plus is de-energized, no, so if you try to look at, so the cylinder does not return, no. So meaning to say, in the case, let's say, no, in the case of the absence of power, so long as you have already energized B plus, then the cylinder will remain in extended position. Okay, so in the case of the single coil, So to enable the cylinder to be in the extended position, you need to have you need to energize always A plus, just like this one. Okay, so it's already in the extended position, but you have to maintain the operation of A plus. No? So and then that can be done using R1. Okay, so the sealing contact. But for the double coil, uh, even if B plus is de-energized, then the cylinder is still in the extended position. Okay, so okay, so how do we make the cylinder to retract? No, for the single coil, so you just press or you just de-energize this one. For the double coil, as I've discussed a while ago, you need to what do you call this one? De-energized or energized B minus. So the other coil, no? So meaning to say we'll have another push button, normally open push button. Okay. So why normally open? Because we intend to de-energize, no? So uh, once we press the push button, so it will energize the other or this B minus coil, no? So just like uh, what we've done, no? So in the first rung of the circuit, we connect the two elements in series. Okay, so just like this one, and then connect it across, no? So this way. So such that if we try to simulate, you energize B plus, the cylinder extend. You energize B minus, the cylinder retracts. Okay, so that's how the double acting cylinder works, no? So energize uh, plus or B plus, cylinder extends, energized B minus. So take note for the double acting, you have their word energized, no? You have to energize the coil. So in order for the cylinder to extend or retract. But for the single acting cylinder using single coil, so all you need to do is energize and de-energize. No? So that is the difference, no, between single acting single coil, I mean, versus the uh, double coil. Okay, so okay, so we'll try to have an example. Okay, so let me. Okay, so this is actually activity number 5. No, your activity number 5. Um, the title of your activity number 5 is Rotary Indexing Table. Okay, so you will be tasked to design activity number 5 using um, the double acting cylinder. Okay, but using 5 two-way double solenoid valve. Okay, so but I'll be implementing activity number 5 now. So in this example, using single coil, and then you will use no, so the um, double coil in your actual activity. Okay, so for activity number 5, so you have there the problem description, no? So using a rotary indexing table, no, so plastic containers are to be separated in linear sequence. Okay. So by pressing a push button switch, the oscillating piston rod of the cylinder drives the rotary table in sequence via a pole. No, so through the reciprocating motion of the piston rod of cylinder 1A. Okay, so let's just omit this one. No, so let's make it when the uh, normally closed. No, let's just say normally closed push button is pressed. So the device, no, so is switch off. Okay, so actually the motion of this one, as mentioned, is reciprocating. That means when you press, no, so the push button, so the cylinder will extend and retract, extend and retract, no, so indefinitely, no, so uh, it will only stop, no, so to extend and retract. It will only stop once the normally closed, no, so, or once a normally closed push button is pressed. So to further illustrate, the operation is somehow similar to a jackhammer, no, so wherein the cylinder extends and then retract, extend, retract, extend, retract. So that's what we will be simulating. Okay, so we try to use a double acting cylinder, so which will create, no, so or design, no, a circuit which will create an oscillating motion, no, of the double acting cylinder. Okay, so but again, I'll be using the single coil, and then you will be using the double coil, no, on your end, no, so when you do the actual activity number 5. Okay, so okay, let me, okay, so again, no, so the motion is oscillating, no, so you press a push button switch, the uh, cylinder will extend, and then you press the normally closed, no, when you press the start push button switch, so the cylinder will extend and retract, no? So it will keep on extending and retracting, no? So until a normally closed push button is pressed. Okay, so what do we do? No, so we need to, or what we need to do is we use, no, so the fluid sim simulator to simulate, no, so the circuit, control circuit, I mean, no, so for activity number 5. So we go back to, okay, so the fluid sim simulator, this one. So let's say we, okay, so we will just ignore the presence of the double coil. Okay, so we will just what you call this one, we will just continue, no, so the circuit uh, or the previous circuit, no, so that we have in or for the single coil, no, single coil 5-way valve. Okay, so or basically we can just uh, delete this one. Okay, and then so for you not to be distracted now, so with the presence of the double coil, no, 5-way valve. Okay, so So by the way, the stop push button can also be placed before, no? So in the circuit. Okay, so okay. So the first objective is to uh, make, no, so control circuit which can, no, so which can what we call this one, enable, no, so the cylinder to extend. Okay, so we can transfer, no, we can transfer the normally closed push button. Perhaps you can transfer it here. Okay. Okay, so strike, so that's the cylinder extends, no? So okay. Now once the cylinder extends, so the cylinder will um, retract automatically, and then after which the cylinder will extend again automatically. No? So as mentioned in the problem. So we have already designed, no? So partly the circuit that will enable the cylinder to extend. Okay, so that is by energizing a plus. No? So the next scenario is to make the cylinder automatically retract. Okay, so how do we make, no, so the cylinder, or how do we enable, no, so the cylinder to retract automatically? Okay, so we use, no, so we use the concept, no, of the sensor, right? Okay, so the sensor, so the A1, no, so the A1 sensor will detect, no, so it will detect that the cylinder is already in extended position, no. So let's just try to create the two sensors first, no. So that's AO and A1. So they're both normally open. Okay, so and then we click read contact, no, label it AO. As you can see, no, so you have there the AO, and then this one read contact, and then A1. So as you can see, A1 is open, AO is closed. So from our last discussion, so I already discussed this one, that your sensor AO is closed because, or the sensor AO is closed, no? So it is because the sensor initially detects, no, that the cylinder is in retracted position. Try to take a look at when we enable, no, so the cylinder to extend. So as soon as cylinder, or as soon as A1 detects now that the cylinder is already in extended position, A1 closes while AO now is open. So why open? Because of course the sensor does not detect, no, that the cylinder in retracted or is in the retracted position. So the A1, or the sensor A1 now detects now that the cylinder is in extended position. That's why we use the concept that when the cylinder or the sensor detects, no, the position or the operation or the status of the cylinder, it closes. Okay, so it's actually open, but as it detects the status of the cylinder, the sensor closes its contact. Okay, so now after enabling the cylinder to okay, let me adjust first this one. Okay, so after enabling the cylinder to extend, and this one, the extend, cylinder extends. So A1 detects now that the cylinder already is in extended position. So therefore, A1 must be able to, okay, so take note, A1 must be able to uh, command the cylinder to retract again. I mean, retract, no? So how do we do it? Uh, we we will find a way wherein A1 must be able to command, no? So the cylinder to retract, no? So we'll just put A1 here. So if you are asking why A1, because uh, the sequence must be from retracted, it will extend, no? So it's cylinder A1 that detects, no? So that uh, it detects the status, no, of the cylinder, which will be the extended position, no? So that would be from retracted position to the extended position, no? So that's why we use A1, because after pressing push button, so the cylinder will extend. So thereby it will be detected by A1. Okay. So we can use, no, so we can use another relay. Let's say R2. Okay, so this would be relay R2. Okay, so we connect them in series, and then we connect them in parallel, no? So to the existing circuit outside, no? So the uh, terminal, no? Or outside the terminal of the stop push button. So which means, no? So if you try to simulate, you look at A1, okay, you focus your attention to A1. So if we start, so as soon as the cylinder extends, it is being detected by A1. So A1 closes, energizing R2. So this is a very critical part, no? So because the next step will enable the cylinder to retract automatically. Okay, so remember, okay, remember always that A1 or the cylinder will only extend, no? So it can only extend if A plus is energized, meaning to say that if the cylinder, no, so or A plus is de-energized, then the cylinder will retract. So we'll try to find a way wherein after R2 is being energized, no? So R2 is being energized by A1. So it will de-energize, no? It will turn off A plus. So if you recall, we have the normally close contact of R2 or relay, no? Or shall we say R2? Okay. Try to take a look at this one. So A1 energizes R2. Once R2 is energized, so the normally closed contact of R2 becomes open. So we will use this part here to make A plus de-energized. No? So just like what I've said a while ago, so if you want that particular component to be de-energized, then it must be connected, no? So or a normally closed contact must be connected in series with it, no? So let's say we want A plus to de-energize, so we connect the normally closed contact of R2 in series with A plus, no? A plus and R1, I mean, no? So okay, so try to take a look at this one, no? So we click start. Okay, so again, no? Sender extends and then retract. Okay, so for you to be able to monitor further, we can reduce, no? So the opening level to 2%. Okay, so just like this one. Okay, so extend and then retract. Okay, so the next step would be, no? So the next step would be uh, to enable, no? So to enable the cylinder to what we call this one, extend again, no? Automatically. So take note, it will only come to a stop once we de-energize, no? Or once we press the normally close push button. Okay, so uh, we try to use AO, no? The sensor AO. So meaning to say, if AO detects that the cylinder is already in the retracted position, so meaning to say, no, so that the cylinder already reaches the retracted position, it will be detected by AO. Okay, so as you can see, you have the AO. Okay, so this part here is very important because we will be designing now, no, so a way to enable the cylinder to extend again. No, so we will be adding components, no, that will make the cylinder extend automatically without the intervention or without the pressing of push button or PB1. Okay, so again, AO is used not to command the cylinder to extend again. So take note that for the cylinder to extend, it's either PB1 or R1. No? So these two. So it's either PB1 or R1 will be closed. No? So if PB1 is closed, A plus will be activated. If R1 is closed, A plus will also be activated. And once A plus is activated, of course, your cylinder will extend. Okay, but how do we enable, no? How do we enable or how do we use AO? Okay, so to command the cylinder to extend again. Okay, so we use another type of or another relay. Now, for example, this is let's say R3. So let's say this is R3. Okay. Now, just like A1, when A1 is when A1 is activated, it energized R2, and then once R2 is energized, it de-energizes A plus, right? So making the cylinder retract. So AO, on the other hand, will command R3. Okay, it will command R3 to be energized, and then R3 will be the one to make the circuit or will make the cylinder extend again. Okay, so how do we do it? So remember, the only way for the cylinder to extend again is to have PB1 or R1 closed. Okay, so when either of this contact is closed, so your A plus coil will be activated and then it will enable the cylinder to extend. Okay, So once R3 is activated, so we'll try to configure the normally open contact of R3. So this is R3. We'll try to configure, no? So that once, okay, uh, let's say put it in, let's say, okay, let's make it this way, no? So when AO is triggered, no? So it will energize R3, thereby this contact here becomes closed, okay? So therefore, we can place, no? So we can place R3 here in parallel, no? So in parallel with R1 or in parallel with PB1. So take note, if PB1 closes, A plus is energized. It will enable the cylinder to extend. Or if R1 is closed, okay, if R1 is closed, then it still can make A plus to be activated because your current will now flow here going to A plus. So A plus is activated. So if R3 is closed, so your current flow will be now to R3 going to A plus. So A plus will also be activated. Okay, that's why we connect the contact of R3, normally open contact of R3 in parallel, no? So with the existing open contact, no? So when you have these three in parallel, this one, it creates the what we so called OR operation. OR means PB1 or R1 or R2, whoever is close, then the A plus coil will be activated. Okay, so now how do we connect AO? No, so with R3, so we connect them in series, and then we now what we call this one, we now connect the two, no, in parallel with the existing circuit, just like what we have done, no? So to the previous circuit, okay? Okay, so, and then if we try to simulate, okay? Now the problem here is that, as you can see, no? So let's say we turn on no? So we turn on the source by uh, clicking the simulation button here. But as you can see, the circuit immediately runs. Although, if you take a look at the operation is already okay, no? So this is what we want, okay? So we can increase the speed, okay? So actually we can increase the speed, and then this one, you can also increase the speed, this one. But then our problem here is that, okay, so problem here is when we turn on the circuit, just like this one, immediately the cylinder, okay, so immediately the cylinder extends, no? So even if we do not press the push button, right? So this is a very dangerous design because we do not know, no? If there is an operator who is not yet ready, but then you turn on the supply and then the equipment is or will run automatically. So we need, that is why we create, no? So the start push button. Okay, so in this case, the normally stop push button is not functioning because once you release the stop push button, So immediately the system will start by itself, no? So that is why we have the start push button. So to enable the system to start when it is triggered by the operator to start. So in this case, just like this one, if you turn on the source by clicking the simulation button, so the system immediately runs. Now, as you can see, it runs directly. Okay, so we'll just try to find a way where we can um, or the system no will start once it is triggered or it is commanded to start. So by the operator, that means upon pressing the uh, start push button. No? So we label this one, so let's say start. So we press, so supposedly the system will start if this push button is pressed. No? But then as you can see, so once you turn on the supply, the system also does not start. Okay. So how do we control or how do we reconstruct now so the circuit? So we'll try to um, use now so the start push button. So actually the main reason why the circuit started automatically is that it will try to remove R3 first. No? So this line here. So if you try to start, as you can see, so initially AO is activated. No? Try to look at AO is activated or triggered, so activating R3. So when R3 is activated, actually R3 here is closed. No? So that is why the current flows, no? So from positive to R3 going to A plus, no? So thereby making the system start by itself, no? Automatically. So to disable this one, so we need R3 to be de-energized during the start, no? Because we want the system to start only when prompted to be started, no? So by the operator, for example. No? So in this case, R3 is energized, so the contact R3 here is closed. No? So we'll try to find a way. Okay. So the position of R3 is okay. However, the problem is that during the startup, R3 here is closed, no, or active, no, or energized, thereby making this closed, so allowing the system to start by itself automatically. So we need something, some revision, no, in the circuit. So the concept of AO, okay, we'll just remove AO first and R3. No? Okay, so now unlike A1, if you try to look at now, unlike A1 during the start is open, if you can see. So the status of A1 is open. So you can connect directly A1 to the uh, output, no, of the stop push button, this one. Okay, so you can connect it this way, no, this point. So A1 can be connected directly to the output of the stop push button because it is open. So meaning to say that it is open initially, then therefore the connected element in series with A1, for example, R2, during at first, R2 is not energized, no, because this is open. However, in the case of AO, you can see AO is closed, right? AO is closed, and then R3 is connected in series with AO. So if AO is closed, it will immediately activate R3. No? So because this is closed, no? Let's say you connect it there, and then this one is connected to this point. So since this is closed, so obviously R3 will be activated directly, and then upon activating R3, of course, this one will close, then circuit current will run through this part and then going to A plus. That is why when we start, no, so when we start the circuit directly extend, no, so without the or with even without the pressing of the start push button. So we'll try to find a way wherein we can let AO to be, we can have AO to be, what we call this one, even if this is closed, it will, or R3 will be de-energized, no, at first. So if you encounter situations like this, no, so particularly the sensor that detects, no, the retracted status of the cylinder. So the secret of the design is not to connect, no, do not connect AO directly to the positive terminal, just like this one. No, do not connect it because it will energize the connected, the series connected element. But you need to, okay, you need to connect AO from the previous rung, okay, meaning to say in this part here, but after the normally open element, which is A1. So A1 is normally open. You do not connect AO to this point, but connect it here. Okay. So, okay, so let me erase while, no. So A1 is connected to R2. So AO will be connected to after A1, just like this one. Okay. So meaning to say, and then R3 will be connected to this point in the negative part. No? So such that if we try to simulate like this one, so even if AO is closed, R1 or AO is closed, right? But R3 is not energized, no? It's not energized because, as you can see, the circuit is open because it is connected after A1. So if we try to start, circuit will extend, okay? Again, no, it will extend and the track automatically. However, the problem arises because the circuit does not extend, no, so by itself automatically. Why? Because after the cylinder retracts, okay, AO closes this part here, it closes. So supposedly it activates R3 and then it enables this auxiliary contact to close and thereby activating A plus again. But the problem is that as soon as the cylinder retracts, now, okay, take note, as soon as the cylinder retracts, A1 becomes open again. Okay, so take note, no? If you let the cylinder extend, okay, try to take a look at this one. I'm holding start push button. So if you try to look at uh, A plus, okay, as the cylinder extends, A1 closes, but when the cylinder retracts, A1 becomes open. So thereby, it's useless for AO to be closed. No, so it still cannot activate R3 because A1 is already open. So take note, A1 will only be in closed position once the cylinder is in extended position. Okay, so try to observe, no? So when the cylinder extends, A1 closes, right? So, okay, so it closes However, as the cylinder retracts, A1 becomes open. So to make AO, okay, to enable AO to operate, no? So for AO to operate, okay, or for R3 to operate, so there must be something that will connect AO to the positive terminal, okay? And that is given by the sealing contact provided by R2, okay? So which means that, okay, so if we put R2 here, and then the principle of a sealing contact is to connect it in uh, parallel, no? So with the normally open contact. So once we start, the circuit does not run by itself, no, because A1 is open. So if the cylinder extends, okay, so again, no, if the cylinder extends, it closes A1, activating R2. Okay, it activates R2. R2 here closes. Okay, so let's try to look at. Okay, so now as soon as the cylinder retracts, now so automatically, so A1 is already open. So this is the one I told you a while ago. So when the cylinder retracts, A1 becomes open. So supposedly R2 will be de-energized, but even if A1 opens, so your R3 is now energized, no? As you can see, because there is, no? So the sealing contact provided by R2, no? As you can see, R2 is open, I mean energized. So even if A1 is open, so the current will pass through, no, the sealing contact. So going to, okay, so current passes here going to R3, and supposedly R3 is activated, but okay, try to take a look at this R3 that's activated, but the circuit does not extend, no? So because the current cannot pass through here. Why? Because R2 is open, because this one here is activated. So we'll try to find a way wherein when R3 is activated, R2 will be, okay, deactivated. So upon activation of R3 with the help of this one, so R2 will also be deactivated. So once R2 is deactivated, this one will be closed. Okay. So once this is closed, R3 is also closed, and then current will pass through here. Okay. So how do we deactivate R2? Okay. So we'll try to do it this way. No. So we'll try to insert, no? So we'll try to insert normally closed contact R3. Okay, so meaning to say R2 will activate R3. Once R3 is activated, this contact here will close, I mean open, it deactivates R2. Okay, so R2 then here will be open again, and R2 here will be closed again. So let's try. No? So okay, so let's try to look at. Okay, so maybe we can incorporate, no? We can include R3, this part here. So you notice that the circuit, no, so does not run. Okay, because the reason is that okay, so when R2 is energized, okay, so let's try to take a look at this one. No? So Okay. So when the cylinder extends, okay, so it closes A1. Okay, let's start it with here. Now, so and then R2 is energized. Okay, so thereby this contact here will close, and then this contact here will be open. Okay, so then the cylinder retracts. No, so the cylinder retracts. So this contact here will be open. So this contact here will open as the cylinder retracts, and then the contact AO will be closed. Okay, so as the cylinder retracts, R3 will be activated. No? So it activates R3. So this one will close, right? Okay, because R3 is activated, right? Now, so this one will close. This one becomes open. Okay. Now, as R3 here becomes open, R2 becomes de-energized. Okay, so then this R2 here becomes open. Okay, so if this becomes open, R3 will be de-energized. Okay, so then this R3 here becomes open again. And then since R2 is already de-energized, so this contact becomes closed again. So what will happen is that the cylinder, no? So the cylinder will not be able to extend again because the moment R2 is closed, R3 is already de-energized. Thereby, this contact here is already what you call this one. This is already open. So we'll try to find a modification. Okay, so wherein we can uh, okay, so we can catch up with the opening, no? Okay, so we'll try to find a way wherein when R3 is activated, okay, when R3 is activated, it will enable the A plus not to be uh, energized, no? So we'll just put it here, okay? So we'll just connect it here. So instead of connecting it before R2, so we'll try to connect it after R2, okay? So connecting it after R2, we'll just simulate it first, no, before I'll explain. Okay, so okay, we have already. Okay, so now why did we? What's the difference now if we connect R3 here versus connecting? Okay, let's use the annotation. No? So what's the difference between connecting R3 here and connecting R3 in this point? Okay, now uh, first is if we consider the connection of R3 here, okay, so as I've mentioned to you, no, so just a while ago, okay, so okay, so when we connect R3 here, so when R2 is energized, okay, so let's start with when R2 is energized, this contact R2 here is open, right? So when this opens, this part here will also close, right? So once the cylinder retracts, okay, once the cylinder retracts, it enables AO to become closed, okay? So once AO is closed, it activates R3. Okay, so as soon as R3 is activated, this contact here is closed. Okay, so the moment this contact here closes, R2 here is still open. Okay, so this is still open because it will be cut off by R3. Okay. Uh, Again, no, R3 is closed here, but R2 is open. So when will R2 here become closed? So it will become closed again when R3 here becomes open. R2 will be de-energized. Okay, so but when R2 is de-energized, so this contact here becomes open. And then once this becomes open, okay, so R3 will also be de-energized. So this contact here will be open again, and then even if, no, so even if R2 is already closed, so it's already useless because R3 is open. So what we need to do is we try to modify, no, so the order of closing and opening of the contacts, no, so by adjusting the connection, no, so what will happen is that, okay, if we connect R3 here, okay, we connect R3 here, okay, so what will happen is that if R2 is energized, okay, so when the cylinder extends, R1 closes, R2 is energized. So this one closes. Okay, so take note, AO is still open, is open at this time, no? So because the cylinder is in extended position, thereby AO is open. Okay, so when R2 is energized, this one closes, this one becomes open. Okay. So again, now when the cylinder extends, it triggers A1. So when the cylinder extends, AO becomes open. Okay, so that's the first thing that will happen. So this one closes, it energizes R2. R2 here will close, R2 here will open. Okay, so then once R2 here opens, A plus will be de-energized, your cylinder will retract. So once the cylinder retracts, no, so this one becomes open because the cylinder will leave. No? So this becomes open, but R2 will remain energized, right? Again, no, so it will remain energized because of the sealing contact. So as soon as the cylinder retracts, it will trigger AO, right? So take note at the same time, at this time, R2 here is open, R2 here is closed. This time AO will close. Now, since AO is closed, current will pass through R2 and then activates R3. Okay. So when R3 is activated, okay, so this part here will be closed. Okay, so once this is closed, okay, so once this is closed, as you can see, it already activates A plus. Okay, so again, it already activates A plus as R3 closes. So together with the activation of A plus, okay, so R3 is closed. So what will happen to this R3 here? This becomes open. R2 will be de-energized. Why? Because this becomes de-energized. This becomes open. This becomes closed again. And then if this is open, so your R3 will be de-energized. This becomes open again, but then your cylinder is already in the extended position. Okay, so that's the difference between we connect R3 here versus R3 here. Okay, so again, now we try to um, connect again. Okay, so we connect it here and then side blade. So notice that the system does not extend by itself. Okay, so it waits for the signal coming from the operator, and then it extend, retract until the operator press the stop button. You can start it again. Okay, and then you can stop. Okay, so uh, another example will be posted. Okay, so after this one, okay, so you simulate this one, understand thoroughly, and another exercises or another example will follow.